Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 12 students in data management who are studying the first unit of the course and are looking for some review material on combinations and permutations. In this video, I'm actually going to look at an entirely new question that I haven't given to you for review. And the reason I'm giving it is, in the other 3 questions that I made videos for recently, they were all permutations or arrangements questions, and I realized I hadn't made a video for you that really emphasized how to make groups or the choosing notation. So here's a brand new question. You haven't seen it before, and I'm going to take it up in this video. And as always, I strongly recommend that at this point you press pause and you try as much of this question as you can on your own, and then resume the video to see the solutions. So here's the question. It says, Adam, Beth, Chris, and 17 others are all interested in being part of a neighborhood cleanup committee. Committee will be made up of 5 members, all selected from the 20 interested people. So what do we know about this question? Well, we're forming a committee out of 20 people, and the committee has to be made up of, has to have 5 members in it. So what's important about a committee that makes this a different question from the other videos I've done is that a committee is where order doesn't matter. So when you make a committee or when you make a group, you're looking at not arranging, not permuting, not placing, but just selecting. So it's really important to note that the group made up of AB is identical to the group made up of BA, and you only want to count that group once. And that's what makes a difference from a permutation or arrangement question. So in particular, we are looking at making out of 20 people a group of 5. So if there's no restrictions at all, the math we would do is 20, choose 5. So we would write it like this, or we would write it like this, or we would write it like this. And again, this is the way that I typically write it, 20, choose 5. There is a button on your calculator, but let me just remind you, in case you need to see this again, that there is actually some more complicated, that the choosing button on your calculator is a short form for the formula. And the formula says n factorial over n minus r factorial r factorial. And so if we were to simplify this, I didn't do this in the other videos, but I figure it's worth going through at least once. So 20 subtract 5 is 15 factorial, and then I have 5 factorial. So again, I could type that into my calculator at this point, but let's reduce. And what I mean by that is if I have 20 factorial and I divide by 15 factorial, there's a lot of simplification that's going to happen. Because if I start to expand 20 factorial, it's 20 times 19 times 18 times 17 times 16. And the next thing would say times 15 and then times 14 and so on, which is exactly what 15 factorial is. So in fact, that's what would be in the numerator, and then the denominator would be 5 times 4 times 3, oops, I don't know why I suddenly changed my multiplication symbol, 5 times 4 times 3 times 2, 2 times 1, and so that's how you would calculate it if we didn't have the fancy button that calculated instantly. Certainly on the test, you can just do this, and then take out your calculator and tell me that the answer is 15,504. Okay, so that's fundamentally what this question is about. It's choosing, in which we have 20 people to make a group of 5, but obviously we have these ABC people who are probably going to be important. So let's look at the first question. So what I've done here is I've sort of created this idea of a group of 5 just to help me visualize what's happening. So we're going to make a group of 5. We want ABC to be part of the committee. So if you imagine putting ABC on the committee, they're on the committee. They're not part of my math anymore. If you wanted to do math, you would say that there are 3 people called Adam, Beth, and Chris, and I want to select all 3 of them for the committee. Of course, 3 choose 3 is equivalent mathematically to the number 1, but logically there it is. Now the problem is, of course, I'm not done because I still have 2 positions on my committee. And the 17 other people, I need to get 2 of them to fill the rest of the committee. So the rest of this question would be that after I've selected ABC from ABC, I still need to select 2 more people from the 17 available. So 17 choose 2, so there would be 136 groups that contain A, B, C, and of course 2 other mystery people. So now I have a question that says that I want none of Adam, Beth, and Chris to be on the committee. Now, one thing I want to say that's really important is this is not the opposite of what we just did. In this question, Adam, Beth, and Chris were all on the committee. In this question, none of them are on the committee, but they're not opposites. There's a committee with Adam, but not Beth and Chris. There's a committee with Chris and Beth, but not Adam. And so on. Like there's Adam and Beth, but not Chris. There's lots of committees that exist that are not either all 3 of them, like in part A, or none of them. So there's a lot of in between. So please make sure you understand that I'm not asking the opposite of part A. What I want now is a committee where A, B, and C are not permitted to be on the committee. And of course, what that means is that all 5 of the people I choose have to come from the 17. So I'm going to do 17 choose 5. If you want, you could put that with 3 choose 0 to indicate that from Adam, Beth, and Chris, I'm selecting none of them. But that again is mathematically equivalent to 1. And then 17 choose 5 is 6,188. So the answer is 6,188. So now I want only one of Adam, Beth, or Chris to be on the committee. So from Adam, Beth, or Chris, one of them is going to be here, and then I have these 4 other positions that will have to come from the 17 others. So first let's decide between Adam, Beth, and Chris, which one. So from the 3 people, Adam, Beth, Chris, I need to choose one, and they get to be on the committee. The other 4 positions, I need to fill from the 17 other people, because I can't let the other 2 be permitted, because otherwise I'd have possibly more than one of Adam, Beth, or Chris. So 3 choose 1 is 3. 17 choose 4 is 2,380. So altogether there are 7,140 groups that have only one of Adam, Beth, and Chris. So what about this situation in particular, where Adam is on the committee, Beth and Chris are not? So Adam is definitely in the committee. It doesn't matter which position I write his name on, because it's a group, so there's no first position or whatever. But Adam for sure is on the committee, and Beth and Chris are for sure not. So obviously then these 4 positions have to be filled from the 17 other people. So if you want, you could do this. There's one person named Adam, and I want him on the committee. There's 2 people named Beth and Chris. I don't want them on the committee. These 2 things are technically mathematically irrelevant, but if you like to see the logic, there it is. The math is really just, once I put Adam on the committee and deny access to Beth and Chris, I just have to now fill the other positions, and I do that by looking at the 17 other people. So really this is 1 times 1 times 17 choose 4, which is 2,380. And so there's 2,380 that contain Adam and none of the others. And one thing that's good to notice is that this number here is exactly 1/3 of this number here, because in this question it was Adam or Beth or Chris, so there should be 3 times as many as just Adam. Now we want Adam on the committee for sure, so there you go. Adam, congratulations, you're on the committee. Then we need one of Beth or Chris, so we can put Beth or Chris here, but only one of them. So the other one, whichever one I don't pick, can't be on the committee, which means these 3 positions, I'll have to fill them with the 17 others. So how would I do this? Well, Adam's definitely on the committee, so you can either mathematically ignore that or say, hey, there's one dude named Adam and I need him on the committee. Between Beth and Chris, those are 2 people, and I need one of them on the committee. And then the rest of the positions, I need to choose from the 17 others, I need to fill 3 positions. So you'll notice that down here, 1, 1, 3, I'm choosing 5 positions, which is what I want. So this is 1 times 2 times 17 choose 3. Oops, hold on, let me throw out my calculator. 17 choose 3. So 1 times 2 times 680. So the answer is that there are 1,380 360 groups made up of Adam for sure, one of his friends, Beth or Chris, and then 3 others. So what about having at least one of Adam, Beth, or Chris on the committee? So there's 2 ways to approach this question, just like there almost always is when we ask at least one. So the longer method would be to do exactly one. So pick exactly one of these guys, put them on the committee, and then the other 4 positions would come from here. So it would look like this. Pick one of those guys, and then the other positions would be filled with strangers or other people. Then I would have to do the math for exactly 2 of them. So I would pick 2 of Adam, Beth, or Chris, and then there's 3 positions to fill. And then I would have to do exactly 3 of them, which would be 3 choose 3, and then 17 choose 2. And these would be the 3 different cases, and I would add them together. So that is certainly not that hard to do, but I'm going to do it the way that I prefer, because usually when it says at least one, it's nice to think about what the complement of that is. The complement of at least one, so the opposite of at least one, is none. So again, if I have at least one, the opposite of at least one is none, or 0. So it's really easy to calculate the number of groups with 0 people and then just do a subtraction. So let's look at what that looks like. So even though we've done the math earlier in the question or earlier in the video, I'm going to kind of repeat it just so we don't have to scroll around too much. There are a total number of possible groups. 20 choose 5 is the total number of groups, all things, all possibilities, all combinations of people. There's 15,504 possible groups. Now, those groups have either at least one of Adam, Beth, or Chris, or if they don't have at least one of them, then they have none of Adam, Beth, or Chris. There's no other possibility, right? You either have none of these guys or you have at least one of these guys. So if I want to find the answer to this question, I'm going to actually find the answer to this question and then subtract from the total, because these are complements. So if I want none of those guys on the committee, then I need to make my committee, all 5 positions would have to come from the 17 people who are not Adam, Beth, or Chris. Hold on, let me just make that a little more, do my math in a little more sense. Okay, there we go. I just like that better because it's underneath none of. So if I want none of them, then I have to make all 5 positions using the 17 people who are not our friends, Adam, Beth, or Chris. And there are 6,188 ways to make the group that way. And that means that every other group will have at least one of them. So this would be 15,504 minus the ones that don't have any of them. And so that would be 9,316. And again, these 2 numbers represent all possible groups. These are the groups without any of Adam, Beth, or Chris. And these are the groups that have at least one of Adam, Beth, or Chris. And this number of 9,316 is the same number I would get if I were to do all of these pieces of math and add them together. So now we have at least 2 of Adam, Beth, and Chris are on the committee. So at least 2 would be 2 or 3. And that's not bad to do mathematically. If I wanted to do the opposite or the complement like we just did, then I would do 0 or 1. So really there's no benefit to doing the complement here. So I'm going to do it straightforward. I'm going to find the 2 different cases where I have 2 or 3. And it is so important to note that I'm about to do bad math here. Ready? I'm just going to do this because I've seen so many people do it and I don't understand why. I've said so many times, please do not do this. It doesn't work, blah, blah, blah. But again, let me show you what you cannot do because I never want to see this. Here is what you cannot do. Hey, if I need at least 2, then I'm going to choose 2 of them because now I have 2. And then that other person, the one I didn't pick, they're allowed to be back in the mix because at least 2, I'm allowed 3. So why don't I just throw them back in the mix when I pick my other 3, because then I could have 2 or 3. Ugh, it doesn't work. And here's one example why. In your 3 choose 2, maybe you chose Adam and Beth. Then you put Chris back in the mix, and maybe you chose Chris and 2 other people, Edward and George. So that's one group that you made using this math. Now another group that you made using this math might be Adam, Chris. So you put Beth back in the pool, and then you selected 3 others, and maybe you chose Greg, Beth, and Edward. Now what you should notice is that this group is exactly the same as this group. So you shouldn't count it as 2 different groups, but you are if you do this bad math. So please don't do that. You have to do cases. So you have to do exactly 2, exactly 3, and then add those together. So I hope that's clear. I really don't want to see that again. It confuses and somewhat irritates me because I wonder, like, you know, what do you do when I talk in the front of the class? Like, you don't trust me? Haha, trust me. I'm doing good math here. So I'm going to do, first of all, exactly 2 of them, which means I'm not allowed 3. Not allowed 3. Has to be 2. Exactly. Oh, I can't spell today. Exactly 2 of them. So out of the 3, Adam, Beth, or Chris, I'm going to choose 2. And then from the 17 others, I need to choose 3 more. So you'll notice that third person, nope, it's either 2 of them, but not that third. So 3 choose 2 times 17 choose 3 is 2040. And again, that is if there are exactly 2 of them on the group. And I also need to consider the case where there are exactly 3 of them on the group. So 3 choose 3, and I have 2 positions to fill, so those have to come from the other people. So that would be 136 different groups. So the total number of committees that can be made that have at least 2, meaning 2 or 3, is the total, which is 2,176. Excellent. So then we get to this part H question, and I just threw it on here because it's sort of interesting to see how far we could extend our understanding of grouping and arranging. So it says, if the 5-member committee is made up of a chairperson, a treasurer, and 3 other members without titles, how many committees can be formed to which Adam, Beth, and Chris are all on the committee, with 2 of them being chairperson and treasurer? So what you'll notice about this is that this diagram sort of no longer applies. So let me get rid of it and try to create a different diagram that might apply. So what we have now is we have a chairperson, a treasurer, and then we have 3 more positions that, oh, it kind of looks like a face, whatever. Then we have 3 more positions that I don't want to consider order for. So it's sort of a mix and match question. So let's see what we can do here, and we're just going to work logically through it. So we need Adam, Beth, and Chris to be on the committee, and we need 2 of them to be the chairperson and the treasurer. So we know that the chairperson is going to be one of Adam, Beth, or Chris. So I have 3 choices to make. Do I choose Adam, Beth, or Chris? Once I've made that decision, I'm now going to choose the treasurer, and I also want it to be from my original group of 3. So once I've selected a chairperson, there's down to 2 other people in the ABC group to be treasurer. So now there's 3 times 2 ways of selecting chairperson and treasurer. So now I have to worry about these 3 positions. Well, whoever was left over between Adam, Beth, or Chris, so the one of them that isn't chairperson or treasurer is definitely going to be here in that group of 3 without title. So I don't need to worry about that person, the math around that, because they're definitely going to be in the mix. What I do have to worry about is these 2 other untitled positions, and those have to be filled by the 17 other people. So that would be doing 17 choose 2. So all of the decisions I have to make are 3 times 2 for chairperson and treasurer, and then 17 choose 2 for the 2 positions that are still remaining after the third ABC person takes a position. So that would be 6 times 17 choose 2, which is so 6 times 136, which is 816. So just keep in mind that, not every question is just exclusively grouping or exclusively arranging, that really understanding combinatorics is just being able to think and apply your learning in different situations. And always remember that everything that we learned in this unit goes right back to the fundamental counting principle about making choices, a series of choices to reach a goal. Okay, so I hope that was helpful. Just remember, please don't just pretend you're studying by watching my videos. They are to support your studying. And the way you have to study math is by taking out your pencil, your calculator, and actually doing a bunch of questions. Okay, good luck studying. Bye.